लाइव होगा साइड आगे नहीं बचे आ जाओ यहाँ माइक पर
he was participated, and he was actively involved in the field of lasers and their thin film growth technology in Kongunadu Arts and Science College. Sir, we are very grateful to have here for hearing your information and knowledge to share among us, the postgraduate and undergraduate student, so that it will be motivate to all. I request you, sir, to share your information with all the participants. And one more information, I request the participant who are already in the Google Meet, you can be here. Those who are not able to join the Google Meet, you can join the YouTube, where also you can easily see the live streaming of this program. Thank you, sir. Now it is turn to Professor Muhammad Ibrahim to share your knowledge, sir.
Yeah,
Yeah, okay,
thank
sir.
you.
Is audible, sir?
It's audible?
Is audible, sir?
Okay. Okay, fine. Thank you. Thank you. Thank you very much, Professor Dr. Muhammad Basa, for the nice introduction and greatly spoken about me in this August gathering. A warm and graceful morning to one and all present here. I'm very much honored and happy to be here as a part of this today's wonderful session, one-day state level webinar on laser and its applications through online platform mode conducted by Department of Physics, C. Abdul Hakeem College, Melvisharam. Before I start, I would like to convey my very sincere gratitude and thanks to the management of C. Abdul Hakeem College, Dr. S. A. Sajid, Principal, Mr. Fayazul Arifin, HOD Department of Physics, C. Abdul Hakeem College, Melvisharam, and my dear friend, Dr. S. Munawar Basa, organizing secretary of this today's event, for having given me this opportunity to talk on laser and its application. Now I will just go on to my presentation part. Just tell me that whether the screen and all is visible or not. Is it okay? Can you able to see the screen?
Yes, okay, sir. Your screen is sharing.
Yeah, fine. Yeah. I hope it's in full view mode. Is it okay?
Yeah. You have to move to the full view mode.
Yeah, it's fine.
Yeah, it's fine, sir. It's fine,
Fine,
sir.
fine. Today the topic what we have taken is laser and its application. The laser, you know very well that the word laser.
Sir,
Very,
just
very.
sorry for disturbance. Sir,
Yes, please.
you have
Yeah.
to rotate your camera because you are seeing in vertical mode now here.
It's okay now. Okay.
Okay, sir. Okay, sir.
It's okay. Fine. It's fine.
Yeah, it's no fine, sir. No fine, sir. Okay, sir. Okay, sir. Now you can proceed, sir.
Yeah, yes, please. Fine.
Okay, sir.
Laser, the word laser, you know very well that it's very, very important nowadays. Almost all the areas, not only physicists, not only chemists, not only scientists, almost even you can say that small child also they are playing with the laser as well as other devices. Like say for an example, laser, the pointer and all. I think you all would please agree with me that some of you might have observed. And nowadays students, for those who going school goers as well as college goers, they all even be playing with the laser pointer or something like that. So laser plays a very, very important role in our day-to-day life. As far as the applications and all, it's enormous applications. Almost all the field we have laser applications are very wide applications. Now we will move slowly one by one. We will discuss one by one. Just basic fundamentals. But before I start, I would like to start with a small quote. If you want to shine like a sun, first you have to burn like a sun. Quoted by the earlier president, Dr. APJ Abdul Kalam. With this quote, I would like to start my today's talk on laser and its application. Always we have to be price as well as loyal to where we are currently attached to the working organization. Myself attached to the Kungunad Arts and Science College. This is exactly located heart of Coimbatore. It's a very nice green campus. We have all the facilities. We all almost the college has established 1973. Almost we have crossed 49 years. If next year comes, almost 50th year. Now recently we have got 36th rank in the NAR of scoring. In the NAR of ranking, we have got 36th place under the able guidance, under the leadership of our Secretary Dr. C.A. Vasuki Madam. She is a dynamic personality and also she is a syndicate member of Bharatiyar University. We have a variety of courses, almost 28 different courses. We have UG as well as PG, both aided as well as unaided stream. This one we will move. Now today's talk, the main outline of this talk will be covering the following informations, like the introduction, what exactly laser, how it is, maybe history of laser, how it comes, what is the full form of laser, all those things we will cover introduction, and then followed by characteristic. History is very, very important. Each and everyone, we have to have some idea about history, background, where exactly we originate, what is our origin, all those things and that's very, very important. We have to have some idea about history, and then followed by characteristics. Characteristics matters much. With the help of characteristics, we can decide where we can apply this particular character, where exactly suits, like that we can decide the characteristics of laser that we will cover. And the next difference between the odd and bright. We have to differentiate, we have to compare. The comparison also we will see, and then followed by three important phenomena like absorption, spontaneous emission, stimulated emission, all the three important properties involved in this laser. So those things we will see. I hope myself is audible. Suppose in case maybe some technical issues may come across, suppose if it is like that, they'll inform me, because I may not know whether myself is connected or not. So you have to hint, you have to give a hint, then only I can be able to come.
Okay, sir. Okay, sir.
Right. Now next we will see the characteristic of stimulated emission. Then afterwards, always we have to have some medium is required. Say for an example, we know very well that sometimes air will act as a medium. Similarly here we will see that what medium actually the laser, how the laser works, what medium exactly required, all those things we will see. And then the most important thing, population inversion. Population inversion is supposed to achieve. We have to achieve the population. How we can achieve the population inversion? And then how to achieve the population inversion? Different procedures, different methods are there. Pumping methods, different procedures are there. Those things we will see. And then optical resonators. With the help of optical resonators, we can achieve the high intense beam. So those things we will see. Then followed by there are different level of pumping we have. 2-level pumping, 3-level pumping, like that. And just an example, just for the sake of example, as less convenient, I will mention only one, the 3-level pumping scheme we will see. And after once we completed, we will see the applications. Little bit we will see that, because I may not know whether, because application alone will take more than 2 hours, 3 hours we can talk. Anyway, we'll see that slowly one by one. Now, introduction, we know very well that everybody agree with me, all physicists, all science students, science background, all everybody is there. Current is amplified. Current is amplified with the help of vacuum tube either or otherwise transistor amplifiers. Once if it is amplified, afterwards we can make use, depends upon our applications. We can make use. So current is amplified with the help of vacuum tube either or otherwise we can amplify with the help of transistor amplifiers. Afterwards we can make use. Right. Same similar way like that here, laser also. Laser is one of the outstanding oscillation was given by A.L. Shallow and C.H. Towns in the year 1958. The first laser, namely the ruby laser was demonstrated practically by T.H. Lyman in the year 1960. Since then, the development of laser has been extremely rapid. Laser action has been demonstrated with solid laser, gas laser, liquid laser, and semiconductor laser. Like that, it's keep on extending. Still, research and it's keep on going. Now, there are four major important properties. That is the characteristic, main major characteristics of laser beam compared to this is very unique. It's very peculiar property. Because of this reason, only laser is very unique. The high directionality either otherwise highly directional. Like that we can say high intensity, high monochromaticity, high degree of coherence. We'll see one by one all. Something we will see slowly with some example. Directionality. What does it mean, directionality? Directionality, that is nothing but just, you know very well, you all everybody agree with me, the conventional light what we have right now, the sodium lamp or tube light, whatever lamp we have, the conventional light source emit light uniformly almost all the direction. Uniformly it spreads almost all the direction. Suppose if you want to have one particular place, suppose if you want to have a narrow beam, then in that case, I hope that everybody is almost after plus two, during plus two, you have done that spectrometer experiment, the way how you did the help of the narrow beam light, how you obtained the help of slit, you would have taken from the light source. Suppose the sodium light source is there. The spectrometer, you have the telescope front side, the back side, you have the collimator. By adjusting the collimator, you can get the shape of the light. You can narrow beam. You can get narrow beam either in the form of triangular shape or otherwise rectangular shape, depends upon the collimator, the way how we have. Suppose if the collimator is triangular shape, then in that case you will get triangular slit. Suppose if the collimator is rectangular shape, then in that case you have rectangular slit. I hope that is very simple example you might have come across. For the ordinary light, the conventional light can get it. But in case of laser, emit light only one direction, and it is angular spread. It is 1 millimeter per meter. The laser beam, let us say 10 centimeter in diameter, when beamed at moon surface, it's 384,000 kilometers away. Is not more than 5 kilometers away. You have a small simple diagram you have. One candle is here left side. Once if you torch this candle, the light is widespread and it will occupy almost all the area of wall. Whereas the laser source, once if it is switched on the laser source, they exactly target one particular place. That is called the directional. So unidirectional, maybe highly directional. The next important property, intensity. Kindly all of you bear with me in today's voice. Kindly excuse and bear with me. Today's voice. If you have any disturbances, kindly those if you are unable to follow me, you can stop at any time. You can ask once again. Intensity, as far as the intensity part is concerned, the ordinary source emits light uniformly in almost all the direction. I already told you the intensity reaching the target. Suppose we want to target any specific area, it's not at all possible. It's very less. It's very less. Can't be able to target any one single point with the help of ordinary source what we have. But in case of laser emit light into a narrow beam, and its energy is concentrated in a small region. The energy, I am talking about this part, energy. Energy plays a very important role for many applications. We have seen that almost we'll be seeing these four characteristics. Each and every character is important for specific applications. We have energy. Its energy is concentrated in a small region. Concentration of energy gives a high intensity of laser beam. Example, 1 milliwatt hour of helium neon laser appears to be brighter than the sunlight. You just imagine brighter than the sunlight. That much intensity we have. And monochromaticity, next part, we come to the monochromaticity. That is nothing but just if light coming from your source have only one single frequency, single wavelength, single frequency, single wavelength of oscillation, the light is said to be monochromatic, and the source is called a monochromatic source. Light from traditional source, what we have, spreads over a wavelength of different ranges from 100 Armstrong to 1000 Armstrong. On the other hand, light from the laser source is highly monochromatic. It contains a very narrow range of few Armstrong. That is the important property, one of the important characteristic of laser, the monochromaticity. Finally, the coherence. The coherence part, light from a source consists of wave trains which combine with each other in a random manner either or zigzag manner. The resultant light is incoherent. In case of laser, a large number of identical photons are emitted through stimulated emission, and therefore they will be in phase with each other. The resultant light exhibits high degree of coherence. When we are able to see the flashlight, how it is, similar way, the flashlight, once it is an ordinary source, the flashlight either or sodium light, once if it is on, it's an incoherent beam, whereas the laser source gives a coherent beam. Now we have a small difference. All everybody's aware. We have noticed. So for what we have covered with that, we can differentiate the ordinary source as well as the laser beam. Ordinary light, the angular spread is more. The angular spread is more, whereas in laser beam, the angular spread is less. The ordinary light are not directional, whereas the laser beam is highly directional. The ordinary light is less intense, whereas the laser beam is a highly intense beam. And then last, it is not a coherent beam. The ordinary light is not a coherent beam and is not in phase. All the waves and all is not in phase. This laser beam, laser source is a coherent beam. It is in phase. The radiations of ordinary light are polychromatic, whereas the laser beam radiations are monochromatic. Some of the examples I have mentioned here: the sunlight, mercury vapor lamp, sodium vapor lamp, all the traditional lamps comes under the category of ordinary light source. Laser beam, you have different categories. You will see that just the example I have mentioned, two different lasers, UV lasers as well as helium neon lasers. We have many other lasers. We will see when we when we see the classification of lasers, we will see all the other few more lasers. Now, there are three important properties I have told: the absorption, spontaneous emission, and stimulated emission. Absorption, everybody know just a simple meaning. Absorption, the way how it absorbs. Absorption, spontaneous word also, we have to correlate all these words with physics, with scientific meaning. Spontaneous emission, everybody's know that emission, different type of emissions you have. Thermionic emission, photoelectric emission, secondary emission, field emission, like we can classify different type of emissions. Very well, emission, that is nothing but just when light comes and hits any object, when light comes and hits any surface, it will emit the electron. So what different type of emissions we have? Thermionic emission, their thermal energy is the main source. Photoelectric emission, the photoelectric voltage, the photo light is important source, like that we can classify. So we'll see that. Absorption, we know that light is absorbed, either absorbed or emitted by atoms or molecules during the transition from one energy state to another state. I hope myself is audible, and is it speeded and it's fine, or anything has to be reduced, or it's okay, comfortable? Everyone can be able to follow me. It's not a problem. You want me to slow because I always used to talk a little fast, so that's why.
It's fine, sir.
That's fine.
It's going
Comfortable.
fine,
Okay,
sir.
fine.
Really.
Now let us consider atom that has only two energy levels, E1 and E2. E1 is nothing but just a lower energy level, and E2 is the higher energy level, E1, E2. When the atom is exposed to light, photon of energy E2 minus A, E1
Sir, voice கேட்கல sir.
Be online, back. Be online, sir. He will back. Okay.
is it fine? Shall I continue now?
Yes, sir.
Am I audible?
Sir,
Okay, fine.
yeah. Now you continue, sir. Now you
Okay,
continue,
fine.
sir.
I don't know what happened. Yes, fine. Fine, now we have that. I think I have covered up till the photons of energy E2 minus E1, so we'll give you H nu. There are three distinct processes used to take place. There are three distinct processes used to take place: absorption, spontaneous emission, stimulated emission. Absorption, spontaneous emission, stimulated emission. Here, first we will see that absorption. Absorption atom is in the ground state, the energy E1, which absorbs the instant photon energy H nu and goes to the excited state E2. That's what you can be able to see in this below. There is no diagram you have. The transition is called what we have covered. We can express in the form of small simple equation. You can understand chemistry and all. Those who chemistry can be able to easily understand A plus H nu. A is the lower energy state. So when additional energy combines, the photon energy combines, the atom moves from excited lower energy state to excited state. That we can symbolically represent A star. The A is an atom in the ground state. A star is the excited atom. If there are many number of atoms in the ground state, each atom will absorb the energy from the instant photon and goes to the excited state. The number of absorption transitions occurring in the material at any instance will be proportional to the number of atoms in the lower energy state E1 and the number of photons in the incident beam. The number of transition, symbolically we can say N suffix A B for second N1 B1 2 into 2. The N1 is the number of atoms in the ground state E1 B1 2. B the subscript 1 2 is the probability of an absorption transition. Q is the energy density of the incident beam. Now the subscript 1 2 represents the transition is from energy level lower energy level E1 to E2. Normally the atom in the excited state will not stay there for a long time. Generally the atoms the excited state, the atoms in the excited state will not stay for a long time. Rather it comes to ground state by emitting a photon energy equal to h nu. This particular emission, such an emission takes place by one of the following two procedures. One is the spontaneous, another one is the stimulated. Spontaneous, stimulated. Spontaneous, the name itself, there is no any additional forces required. There is no any external triggering forces not at all required. Spontaneously it will take place. The atom in the excited state E2 returns to the ground state E1, that is the lower energy state, by emitting a photon of energy E equal to h nu, that is E2 minus E1, spontaneously without any external triggering force. This process is known as spontaneous emission. So this also can be expressed in the form of A star. A star is the excited state. When you come to the ground state, it will emit A plus h nu. It is the energy h nu. Now here you have a small simple diagram. You can be able to see that before atom is excited state, and then during the excitation process, how it moves, and then after the excitation, it will photon. It will emit the photon. That's what you can be able to see in the red color arrow mark. Photon comes in the form of energy. The number of spontaneous transition depends only on the number of atoms N2 at the excited state E2. Therefore, the rate of spontaneous transition is given by the simple equation NSP is equal to N2 A21. The N2 is the number of atoms in the excited state E2. A21 is the probability of spontaneous transition per unit time. The subscript A21 represents the transition from energy level E2 to E1. Now we will move on to next one, important one, stimulated emission. Here you have the diagram, simple diagram. If you see, you can be able to understand. Anyway, we will give slight explanation. I will touch this area. The atom in the excited state need not wait for spontaneous emission of photon. There exists an alternative mechanism by which an excited atom can make a downward transition from lower energy level to higher energy level to lower energy level and emits a radiation. The photon energy h nu equal to E2 minus E1 can include the excited atom to make a downward transition releasing the energy in the form of photon. Transition generates a second photon, should be identical to triggering photon in respect to the frequency, phase propagation, and direction. The phenomena of forced photon emission by an excited atom due to the action of an external energy is called. Here, the external energy plays an important role. That's why it's called either stimulated emission or otherwise we can say that induced emission. This we can write it in the form of small simple equation. A star plus H nu combined together will give you A plus 2 H nu. 2 H nu. Earlier we have seen that 1 H nu. Here we have that 2 H nu. Like that, the population may involve. I mean that it will double, triple like that. Go on. The number of stimulated emission MST per unit volume per second. MST is equal to B21 N2Q. But B21 is the probability of stimulated transition. This is the major three important things: absorption, spontaneous emission, and stimulated emission. Now, this all the process and all used to take place. How we need some medium is done. Atoms are in general characterized by a large number of energy levels. However, all type of atoms are not suitable for laser operation. Right? We have to choose, we have to select. Even in a medium consisting of different species of atoms, only a small fraction of atoms of a particular type of energy level system suitable for achieving the population inversion. Such an atom can produce more stimulated emissions than the spontaneous emission or amplification of light. Those atoms which cause laser action are called active centers. Those particular laser actions are called active centers. The medium hosting the active center is called the active medium. This particular medium is called active medium. An active medium is the medium which, when the exciter reaches the state of population inversion and promotes stimulated emissions, leading to light amplification. Now we have the next important aspect, the population inversion. Let N1 be the number of atoms in the ground state. N1 immediately 1. It is N1, then you have to correlate B1. That is a lower energy state or ground energy state. But N2 be the number of atoms in the excited state. Usually at thermal equilibrium, the number of atoms N2, that is population of higher energy state, is much lesser than the population of lower energy state N2. That is N1 is greater than N2. Normal condition, N1 is greater than N2. It is thermal equilibrium condition. After population inversion achieved, N2 is greater than N1. The phenomenon of making N2 is greater than N1, that is, the number of atoms N2 is higher energy state is more than the number of atoms N1. Lower energy state is called population inversion. This is what this process is called, population inversion. This can be achieved by some of the important properties. This can be achieved by some. Somebody has to mute the minutes. I think someone has to mute, I think, by mistake.
Participant, please mute your audio and video. Participant.
Okay, fine. Google. Okay, fine. Now, pumping method, there are different pumping procedures, pumping methods are there. The process of raising more number of atoms from lower energy level to higher energy level is called pumping process. There are different pumping processes out there. I'm not going to deal all these things. Just example, I have mentioned that there are 5 different pumping procedures. Optical pumping is nothing but just excitation by photons. Some of the examples I have mentioned, UV laser and the LDR laser works mainly based on this particular pumping process. The electrical discharge, the excitation by electrons, the argon laser, helium laser, CO2 laser, that is carbon dioxide laser, all those lasers works under this pumping method. There is a direct method. Direct method, that is nothing but just electrical energy is converted into light energy. Example, semiconductor laser. Under the semiconductor laser, you know very well that is the homojunction laser, heterojunction laser, like the different lasers are there. The inelastic atom, that is mainly because of the atom collision. Example, helium again, once again, the helium laser, CO2 laser is the example for inelastic atom. Chemical method. There is a chemical method. Example, dye laser, different dyes we have to make use. And one thing I would like to highlight the semiconductor. Semiconductor, you know very well that semiconductor is partially conducts current. Semiconductor, you have semiconductor. There are two different types of semiconductors: intrinsic semiconductor and extrinsic semiconductor. Intrinsic, extrinsic. Extrinsic, the intrinsic is the pure form of semiconductor. Extrinsic semiconductor is the externally doped. Under this condition, you have p-type, n-type. When pentavalent is added, that is n-type semiconductor. When trivalent is added, that is p-type semiconductor. Then inelastic atom, elastic collision, inelastic collision. When the momentum is conserved, it's elastic. Momentum is not conserved, then it is inelastic. All those things just I would like to touch. Now we will see that there are three different level of pumpings we have. Just for the sake of convenience as well as for better understanding, I will take only one 3-level pumping. Similarly, we have 2-level pumping, 4-level pumping, like different levels of pumpings we have. Now I have taken this 3-level pumping. The state E1 is the ground state level, E3 is the pumping level, and E2 is the metastable upper lacing level. E2, there are 3 lines you have. You can see that the ground state, that is E1, E2 is your metastable state. The last third, the upper one, uppermost is the E3 is the pumping level. When the medium is exposed to pump, frequency radiation, a large number of atoms will be excited to E3. However, it will not stay for long time. The level but rapidly undergo downward transition from E3 to E2. The metastable state E2 through the non-radiative transition. Non-radiative transition, the process is called fast decay. Fast decay. The atoms are trapped at this spontaneous transition from the level E2 to the level E1 is forbidden. Pumping continues, and after a short time, the level will be a large accumulation of atoms at the level E2. When more than half of the ground level atoms accumulate at E2, population inversion condition is achieved between the levels E1 and E2. And the chance photon can trigger stimulated emission. This is very important. How much you can get the laser. Now you have that resonator. Resonator is very, very important. Why it is important, we will see. If you want to have high intense, you have to make this optical resonator. Optical cavity consists of 2 reflecting mirrors. One is 100% enclosed by the cavity. One of the mirror is 100% reflecting, other is partially reflecting mirror. Let some of the radiation pass through. The optical cavity is used to make stimulated emission possible in more number of atoms in the active medium. This naturally increases the intensity of the laser beam. Intensity of the laser beam increased by using these optical resolators. Now we have the rest almost 20 minutes. Types of laser. There are different types of laser. Lasers are classified into 5 major categories. This just says for the sake of the example, I will mention only 5 lasers. In addition to that, other lasers also, the excimer laser, many other lasers are there. I have pointed out only 5 important lasers. Solid state laser. Example for solid state laser is the ruby laser, MDR laser. These are the lasers. This is an example for solid state laser. Gas lasers. Obviously, the CO2 laser, carbon dioxide laser, helium laser, all comes under the category. Argon lasers, all those comes under the category of gas laser. Example, gas laser. Semiconductor laser, the gallium arsenide laser is the small simple example for semiconductor laser. Liquid laser, we have examples. Europium benzoyl acetone dissolved in alcohol. This is a kind of liquid laser. Sometimes the liquid laser is also called a dye laser. Chemical lasers, examples, chemical oxygen and iodine, hydrogen fluoride and iodine fluoride, TF lasers also used as an example for chemical lasers. Now you have high-end as well as low-level lasers. High-level lasers, you have surgical lasers. With the help of surgical lasers, you can perform a number of surgeries. Surgeries can be performed by using these surgical lasers. Hard lasers, The thermal energy is between 3000 to 10,000 watt. Low level lasers or medical lasers, soft lasers, subthermal energy is between 1 to 1500 watt. Therapeutic cold lasers produce maximum output of 90 milliwatt or less, 600 to 1000 nanometer light source. Now, we'll see only one small simple example. The NDR laser, the principle, as well as the way how it works. Professor Munawar, shall I continue now? I think few more slides, and then afterwards we'll cover some of the applications. Is it okay? No problem? Comfortable now? 5 to 10 minutes will wind up. Is it okay?
Okay, sir. Okay, sir. Okay, sir.
Right. Now we will see one small simple example, the NDR laser, the way how it works, major principle, as well as the working mode, how it works. You will see. You have the small simple diagram. NDR laser, instead of following all, just only one small simple laser example of the example I have taken. The active medium is NDR rod. The neodymium ion has many energy levels. The rod is the neodymium ion has many energy levels. With optical pumping, these ions are raised to excited levels. During the transition from metastable state to ground state, the laser beam of wavelength 1.064 micrometer is emitted. A small simple construction. This diagram you have seen how it is, looks like laser, flash tube, elliptical cavity capacitor, optical resonators, that is partial reflector mirror. One is 100% the left hand side, right hand side you have partially reflecting mirror. Now everything is connected to power supply, simple power supply as well as resistor is also connected. The York crystal rod is taken in the form of cylindrical rod about 10 centimeter in length and 12 mm in diameter. York crystal yttrium ions O3 plus are replaced by neodymium ions Nd3 plus. Neodymium ions are pumped by Krypton glass lamp, a laser rod, and a pumping source that is called the hush tube are placed inside a highly elliptical reflector cavity in such a way that most of the radiation from the flash tube passes through the laser rod. The flash tube is switched on, controlled with the help of a capacitor. The ends of the rod are polished, made optically flat and parallel. The optical resonator is formed by using two external reflecting mirrors. One is 100% reflecting one. Another one is the partially reflecting one, which is included to increase the efficiency of the output beam. The system is cooled by either air or otherwise water circulation. And the way how it works, there are a few points out there. The Krypton glass lamp is switched on. The light is allowed to fall on the laser rod. Intense white light excites the neodymium ions are raised from the ground energy level V0 to upper level E3 and E4. From these levels, neodymium ions make non-radiative transition and is gathered in a state called as metastable state. The population inversion takes place between E2 to E1, emitting a photon. The emitted photon will trigger a chain of stimulated photons between E2 and E1. The photons the generator are allowed to travel back and forth between two mirrors and grow in strength. After once if the enough strength is attained, an intense laser light of wavelength 1.064 micrometer is emitted to the parallel reflector. Transition from E1 to E0 is rapid and non-radioactive. Now we have a small simple energy level diagram of the one what you've seen right now, the NDR laser, how it works, energy level from Z0. The dotted line indicates E0 level, the E1 level, E2 level, E3, E4 like that. It's keep on increasing. That is nothing but just you have seen that 1s, 2s level, 2p level, all this are the energy level diagram. And you have the fast non-radiative transition. Here you have the metastable state. This E3 is your metastable state. The laser comes out between the state E3 and E2. The range of 1.06 micrometer. Now, application, as far as I already told you that application, I just roughly I have covered a few areas. Application alone will take almost more than 2 hours, 3 hours. We can talk any number of applications, enormous application. Now we have seen that you mentioned that some of the applications like laser in computer works different applications you have in computer, industrial applications like welding, cutting, all those things are industrial applications. Laser in communication. Communications, you have a lot of underwater communication, right? The fiber optic communications, everywhere laser plays an important role. Laser in medicine, you know very well that nowadays the bloodless surgery is achieved with the help of laser. Earlier days and all are complicated, very complicated, particularly surgery like the eye surgery, removing cataract, it's very difficult. So a lot of complications, patients used to stay more than a week. Nowadays, it's not like that, just a matter of 4 hours, you can go, you can come back after having surgery. So cataract can be removed. The LASIK surgery, that is instead of lens, we can make use, instead of lens, you can use that surgery is called a LASIK surgery. Consumer electronics industry, it's very widely used. Nowadays, almost all the electronics, everything is mainly based on the laser in metallurgy, laser in chemistry, particularly in chemistry, the paint industry, and it's very widely used. Coagulation techniques is involved in this. Laser in chemistry, laser in photography, lithography, all everywhere it's used. Photography, laser in photography, that is holography, all everything is mainly based on laser. Laser in detection and ranging, the way how it is radar, they same similar way laser in detection and ranging, that is called LIDAR, LIDAR. Laser in nuclear energy, laser in government energy. Some of the applications you can be able to see, say for example, retina. The retina treatment can be adjusted wherever you have. Suppose the retina is infected, then exactly we have to pass the laser beam and we can correct. The retina can be adjusted and corrected with the help of laser. This is what I told. The laser eye surgery, that is cornea. Cornea can be adjusted. Cornea can be adjusted with the help of laser. You know very well that I don't know how many of you observe. Suppose if you have any eye defect, suppose if you press your eye a little bit, you can have the clear image. That is mainly because of the cornea adjustment. Cornea has to be adjusted and can be performed with the help of laser source. Laser surgery in revascularization. This is nothing but some of the patients' body will not cooperate with the stent or otherwise that angiogram. For those patients, they have to undergo, they have to disconnected. Fine. That's what laser surgery is performed. That is revascularization. Revascularization, that is nothing but for those who some of their body may not cooperate for angiogram, stent. Those people they have to undergo this laser surgery, revascularization. Laser skin rejuvenation. Laser skin rejuvenation because of the happening old age. This is nothing but just the skin replaced layer by layer. Layer by layer, the skin can be replaced. You can get new skin. Laser skin rejuvenation. You can be able to see that because of this old age you have left hand side, and that after rejuvenation you have the perfect skin. The laser hair removal, unwanted hairs can be removed using laser hair removal. Laser removal of tattoo. Tattoo, you know very well that in some of the community, I think the tattoo, in tattoo and all, it's haram. It's not permissible. It's not permissible. It's not permitted to put tattoos and all. Sometimes because of friend circle, because of some pressure, some of them might have done that, but it can be removed. Tattoo can be removed by using this laser treatment. And now, almost we have come to an end. This is some of the facilities what we have in our lab. There are three you have been able to see. I'm just sitting inside this lab only. This research lab we have. All the facilities we have. The first one, left hand side, what you are seeing here is the plasma arc deposition unit. Then high temperature muffle furnace, pelletizer. The next followed by you have the hall measurement, IV current voltage measurement setup, characteristics setup, all everything. Now almost we have come to an end. Before that, I would like to show what are all the facilities we have in our research lab as well as other labs. We have that this one, the left hand side, what you are seeing, that CVD, chemical vapor deposition, it is spray pyrolysis. The next to CVD, you have thermal evaporation unit. In addition to that, we have radio frequency DC, parallel spectrum also we have. I think one of the it is working now. Inside this doing some filling deposition now. And the next one, we have that automated spray pyrolysis setup. Automated spray pyrolysis systems. And similarly, we have deep coating also. Deep coating we have. And then ultraviolet agitator. Ultraviolet agitator we have. Followed by you have UV visible spectroscopy, photoluminescence spectroscopy, 4 probe method, 4 probe, and then Melvisharam. Yeah, before I conclude, just I would like to take almost we can conclude, it seems. Is it okay? Fine. Professor Manohar Bhatta, is it okay? Will you friend?
Yes, sir. Yes, sir. Yes, sir. Yeah,
okay.
Sir. You conclude, sir.
Fine. Almost time since it seems. Now, before I conclude this, I would like to say that thus we find that one of the most widely used electronic devices of the era is laser. The very high power lasers cost in hundreds of rupees. Small diode lasers cost only a matter of tens of rupees. Even these lasers can be used in fabricating laser-based instruments. Nowadays, there is no field where lasers are not being used. Before I share time to, I would like to quote the important word: search for knowledge. Search for knowledge, even if it may be as far as in China. Once again, I will repeat: search for knowledge, even if maybe as far as even in China. This is the important quote given by one of our Prophet Muhammad. Before him has spoken. Kindly search knowledge wherever it is. This is what from my side I would like to conclude. Questions are always welcome. You can raise questions if you have any questions. We will get to answer. And similarly, I will put a one small feedback link. Kindly fill up this feedback link and you can send it to me. I'm posting the feedback now in the chat box. Kindly all of you fill up.
Thank you, Professor, for giving us such a wonderful talk. It is really useful for our student and most of us, because most of the students are undergraduate and postgraduate. They have all this in their syllabus as well. So there, I think in the 6th semester they have one atomic physics paper. 5th semester they are very useful for them, because we have one unit itself regarding the laser. So your information and basic knowledge on this is very helpful for. So I agree with. Yes, sir.
Yes, please.
I agree. Few students, if any participant have any clarification, they are open to talk now.
Yes, that's what.
I take only few questions, sir, because of the time constraint. I ask one or two students to clarify if you have any doubt.
Yeah. Suppose if there is no questions, in that case I will start asking questions.
Yeah. Somebody has in between has raised their hand. Yeah, who is that? Can you ask some participant has put some question in between.
Okay, I think I have seen one question. It seems what makes a laser more powerful? It seems someone asked. It seems.
Okay, sir. Yeah.
Actually, the most important factor of the high power laser is the actual strength of the beam itself. Actual strength of the beam itself, regardless of the color, whether it is sometimes you have blue color, red color, something like that. The laser that can light a match or balloon or cut the electrical tape, even electrical tape, you have 200 millivolt or 300 milliwatts. The higher power energy here, the power plays a very important role. That intense beam, the beam intensity plays a very important role as well as the powerful. What makes a laser more powerful? This is the answer for this question.
Yeah. Sir, one question is here. What the role of laser in the nuclear field? As you mentioned in one of the slides, they are asking,
yes.
What is the role of laser in the nuclear field?
Okay, okay.
Yeah, yeah. So one more question
Sure. Yeah.
from the participant. What is the technology that are using in the defense in order to
Defense
have
side.
defense
Ah,
side, the laser
yes, yes,
technology? Nowadays, there are some laser based missiles are all
yes,
available.
that,
So which type of laser are the in regarding that there is a question one, sir.
yes, yes. Okay. The laser, as far as this defense, very wide range of applications are there, particularly laser guided
Mm,
anti-tank missile, ATM, that is laser guided
okay, sir.
anti-tank missile. This is one of the important aspects. That's what currently in India, Indian Army is using. The most powerful laser weapon in the army is that is the that laser is called ultra short pulse laser. That is U.S. Army is
Ultra.
using the call to develop the ultra short pulse laser. That is the most powerful laser used in the defense. The U.S. Army is using the call to develop an ultra short pulse laser. This particular laser is designed to unleash enormous power in a fraction of the time. Fraction of a time, it will attack. It's not like the normal laser.
Okay, sir. Okay. So I hope the participant had got the information. Sir, it is wonderful for you the talk that you have shared with us, the knowledge. Now I request my colleague, Dr. I. Muhammad Ikram, to have a vote of thanks for this program.
Thank you, Dr.
Second week.
Thank you, Dr. Mona Basha. Uh, so, gratitude is a quality similar to electricity. It must be produced and discharged and used up in order to exist at all. I am very much humbled and honored to be the one making the closing remarks and giving a vote of thanks to such a distinguished and stimulating gathering who made this day an intellectually sweet memory to carry home. It gives me immense pleasure to thank our chief guest, Dr. Muhammad Ibrahim, who honored this function with his intense, amplified, and stimulating as well as extremely important talk on laser and its application. Thank you very much, sir. I would like to thank our beloved principal who had enlightened this event and had formally flinched the state level seminar. Heartfelt thank you, sir. Now, it is time to show our heartily gratitude to our most humble and electrifying head of our department, Professor Fayazul Arifin, for being very supportive in every way for the smooth functioning of this event. My heartfelt thank you, sir. A successful warrior is an average man with an extraordinary focus. I feel excited to thank the warrior of the day, Dr. Munawar Basha, who is an extraordinary man with extraordinary focus for organizing and taking complete responsibility of the event and making it successful. Tons of thanks for you, sir. I would take this opportunity to thank all the faculties of our Department of Physics to joining their hands on this fruitful occasion. You cannot fail without your consent. You cannot success without participants. I, on behalf of Department of Physics, thank all the participants of C. Abdul Hakeem College and other colleges for actively participating on this state level seminar. My work will not be completed if I fail to thank the support team. Last but not the least, I heartily thank our alumni Atiq Ahmed, who took his time to support us in technological aspect. Thank you all very much.
Fine. Just one thing, please.
Yes.
Just now, I noticed one question. I think, Zaida, why green lasers are used most? The green lasers are used by astronomers. Mostly astronomers they have to point out to the
Mhm.
celestial bodies. This type of laser is more effective, particularly astronomical purpose, than other colored lasers. The other color, instead of using other red color and all, this is mostly astronomers. This is mainly because of its power only. Even we can point
Yeah,
out the moons from here, from ground level, from here itself, we can point out where exactly what is what. Like that, it will reach. The main reason is power. The green laser can be used, particularly astronomy by hand, or by attaching them to a telescope. There itself we can attach. The telescope itself we can attach. Once again, I request all the participants to fill up the feedback form. Suppose if you need any assistance, maybe feel free to discuss. You are always welcome when you have a chance of visiting Coimbatore. You can come and visit us. Always feel free. Right. Shall I sign off?
Thank you,
Professor?
Professor. Yes, sir. Thank you, Professor. One request from you. Please, you can share your presentation so that we can share with the participant.
Yeah. Sure,
And
sure.
I also request the participant to give your feedback so that you can have your all e-certificate. So there is
Yes,
some
yes,
simple question you have to answer. All the participant, I request all the participant to do the feedback as soon as possible. The professor, thank you for your taking the time so much and having a webinar with us. Thank you very much, professor.
Thank you. Thank you. Thank you very much for the opportunity given. Thank you.
Okay, thank you. Now you can leave, sir.